guys probably heard. Yeah. Or if you're from North Carolina, you know you don't have school like for 2 weeks if it snows an inch, right? That's what happens here.
More like all year.
I mean, it's remarkable.
It's remarkable. No school. No school. No school. But in Massachusetts, if it snows an inch, like, it doesn't matter. Doesn't matter. So we were actually gonna go through this lecture on Tuesday. So it's gonna be a little bit of review because some of the slides are dealing with some geoprocessing tasks that you guys have been working on. How are your labs? Everybody okay on labs? I tried to make it more manageable for you this week. Did it make a difference? Yeah? Yep. Uh-huh.
Yeah.
The grading was messed up. Yeah, if you didn't have like.
We had to choose the right primary.
Oh. Yeah. Oh, right. Sure, I'll go back and go through them. You guys got your responses though. You got feedback on it.
Yeah.
Okay. One step at a time. So will you guys email me if you know that you had that problem, so I'll be sure to check it if you caught it. Otherwise it may. There's a lot of things going on these days. Okay, and I don't know
why. I thought I published it on Friday for you. I don't know what happened that it didn't come out, but it should be fine. Everybody did it, right?
Okay, so we went through in our last lecture a bunch of these, some of our geoprocessing tools. All should seem sort of familiar
to you guys now. In summary, remember you've got these different options, whether or not you want to retain your attributes or not, what sort of join you want to have, and we've talked about these a lot, the clip, the intersect, and the union. They should all seem pretty familiar to you all now, right? Feeling comfortable with those? Okay. Just another summary slide of what we end up with depending upon which overlay function we're going to go with, if we want to keep everything or if we just want a subsect of it with intersection. So some of the other ones that we're going to talk about today now are in your toolbox. You guys did an exercise with buffer for your lab, but we're going to go through that as well as append, merge, and these two, which we'll just go quickly over because we don't have the tools in our toolkit yet. So buffer should seem like a pretty standard analysis for you guys, especially being in biology. Whenever you need to know things that are within a certain distance of another thing. So we do that a lot with protected areas, with rivers. If you're thinking about doing types of analysis for commercial applications, they do a lot of buffers for like, where's the closest Trader Joe's? What size buffer do you need to have to put the next Trader Joe's or Whole Foods or all these things? And that's how they figure out a lot of the placement of new franchises. So not just ecological applications, but all sorts of other ones. And you have different options when you're using buffers in GIS, the single versus the multiple rings, if you're going to buffer outwards or if you're going to buffer inwards. And so depending upon what type of analysis you need to do for that buffer, you will choose different options. And what you end up with is a new map, which is going to be an output map, which is going to give you those buffer areas, those polygons. So these look pretty familiar, right? Buffers around points, buffers around rivers. You specify those distances. Another example here, if you were looking at hospital locations and trying to identify areas that had needed more access to hospitals, or maybe where you had to have, say, more EMT services to get people to hospitals, so you'd have your point locations of hospitals and then do different rings. You guys remember a slide from last week where we were talking about one problem with this kind of straight up analysis of walking distance, maybe? Yeah, remember that word, an anisotropic surface? It's not even in all directions. There could be different things that were causing it, like maybe you can't cross this highway on foot. So although it's a simple buffer here, yeah. Uh-huh. Yeah, that's a good idea. I don't know if there's something that you could do straightforward in your buffer module, but you could build that into a tool where you could pull out those attributes and then do a separate type of buffer for those. But I think what you would do is you would just sort of design your own step there, like a identify all hazardous waste that are maybe active. As if you guys have noticed, in a lot of those hazardous waste sites, they're just places that have potential for contamination, not necessarily that have had contamination. So something like that you would do, and you would just add a step in and then do a different type of buffer. So you could automate it, but within that module, no. Okay, so this is just looking at a point example. You guys did a great job, I'm sure, with your labs doing buffering lines, looking at rivers. But that's another case where you might want to think about doing a different type of buffer for different types of rivers, like your main larger rivers versus secondary may not need as large of a buffer, or other things you would want to combine there. Polygons. So you guys are familiar with this guy, right? Your buffer tool. And did you know about the dissolve option? Were you guys working with the dissolve option in your labs? So what dissolve does, maybe I'll turn this guy off. You can see how buffer's going to build those polygons around each feature. And so when you use your dissolve option, it creates a single a single polygon as opposed to keeping them all separate here. So usually I'm dissolving my buffers. If you didn't know about that and you didn't do it, it's okay. We didn't go through this yet. Okay, so that's the overview of buffer. Append is another tool where what you're doing in append is you're taking your features from one existing feature class and you're adding it to another feature class. It's the same sort of idea as union, except it's not going to split your features. They're just going to get overlaid on top of each other. So in this case, if you had an area where there was a stream in one layer and you were adding in another, you'd end up with two separate stream lines in it. With append, your attributes have to be exactly the same. Your attribute tables have to be exactly the same. So it's a little bit rigid. So what you do is you're adding another data. You have an existing data set. You want to add something to that. That's when you would use the append tool. Again, the features have to be the same types. They can overlap one another. And you have two options here where you can test it to see, to make sure that all of your feature classes are going to be the same and in the same order. And if you don't use the test option, they don't have to match exactly. So here's an example here where you're using it to combine two different counties. You need just a single street map. So these are two separate files here. So under append, under your general set of tools, and you end up with this single layer where everything is combined into one. And you can see here that you end up with the same, your shapefile is just taking, your attribute table is combined with both of them. So merge is really similar to append, but it's a little bit more flexible because your input tables don't need to match exactly. And and you specify what types of fields you want included in that output. So you can choose not to include some of the attributes, unlike append, where it's going to combine all of them. And just like append, you can have those overlaps, and what you'll end up with is those two features instead of joining them together. So with merge, you're going to combine multiple data sets into this that have the same type into a new output data set. An example of where you might want to do this is looking at trying to create a voting map, but you want to keep the original layers. You don't want to modify those original layers and add something to it, so you can use merge, and you end up with a new map. And again, you can choose which ones of those attributes you want to retain. You may not want to keep everything. Okay, so again, tools that we don't have, update. I don't know why I'm putting these in here for you guys, but there are other tools out there. Identity is another one we don't have. Sorry. But I guess the point is that they're constantly updating and giving you different geoprocessing tools in every new release of ArcGIS. Something's changed. So you can always go onto the Esri website and find out about different geoprocessing tools that are in the works, or things that may be available in an updated version of ArcGIS. And there's also, hold on, escape from here for a second. Inside of Arc, there's a user community, a geoprocessing user community, where people may build tools. Remember how in Model Builder you can create a model and then save it. It gets saved as its own tool. You can share those tools with other people. And sometimes people share them with a broader community. Let me see if I can. This guy. Under geoprocessing, there's this Geoprocessing Resource Center button. You can register yourself, and then you can download different tools. This is a bunch of tools that people have created that they're sharing, that you can use inside of ArcGIS. The one problem is that a lot of them are going to require later versions of ArcGIS because they're new. So you have to search around to find things that you could use in 10.0. I find that a little bit annoying, but there are things that are available for 10.0. So that was just, it's at the bottom of your geoprocessing button, geoprocessing tab here. And you guys should search around and see if there are things that might be of use to you and you're thinking about doing. I think I've told you before that the Esri website is really a great resource. Whenever you're stuck or if you have questions about things, they have a really extensive help menu. Okay. So the other thing that we talked about briefly last time was going through and figuring out how to automate your tasks in GIS. Because frequently when you're doing geoprocessing, you end up having a set of steps in an analysis that you're going to do over and over and over again. It's just really common that you figure out one process and then you have to repeat it. So by building things like models or using Python scripting, you can make your processing tasks a lot easier. So I know I showed you how to do that. Did you guys play around with that at all on your own, building your own models? No? Okay. Well, we'll play around with it a little bit more, not in this week's lab, but it's definitely something worth familiar if you're going to work in GIS more. It's pretty intuitive, though, because what it really does is it helps you not only automate your process, but it also helps you think about the steps that you have to go through for any kind of an analysis. And this is helpful for you guys when you're thinking about how to do something. And it's also helpful for sharing those with other people so that they understand exactly all of those processing steps that you go through. Because in GIS, it can be a little bit like a black box where you end up with this map in the end, and you're sharing it with people, but if they don't understand how it was created, it could be, maybe they won't understand exactly what the data is that you're sharing, or how they might want to go about recreating that process somewhere else. So this is just showing you guys, and I think I've told you a little bit about this, how you're going to go from, say, a population, trying to figure out potential park sites based upon different things like your existing park locations, your population, and the other term besides model builder, which is what we use in ARC, is cartographic modeling. So that's the sort of big term we use when we're talking about laying out that analysis process. And we can do that in different types of ways. And it looks different depending upon which program we're using, but every program is going to give you an option for doing this. So inside of ArcGIS, these are the different tools that you can do. You guys are familiar with executing geoprocessing with your toolbox now, and with the different menu options that you end up with. This is showing you what your what your model builder looks like. There's also, you can do it through command line if you guys are comfortable with that, or through Python, through script. Again, so cartographic modeling, most broadly, it's how you're laying out your whole analysis process, your workflow, how you're going to use all of your different GIS functions, your tools, and that logical process, the sequence that you're going to go through to solve your problem. So again, the advantages of it is that you're able to speed up your processing because you're going to string together all of those analysis steps. And everything will be performed sequentially for you. You don't have to go in and load one map and then load another map, which can become pretty time-consuming and unnecessary, really. And then it's also great because you can repeat the analysis more than once. So whenever you're building models, you're building it from a set of different tools together. And again, you can share those with other people. You can save your model as a tool. You can save it as a separate toolbox. You could share it. So if somebody figured out how to do the lab really fast and built a model, you could share it with everybody. Then you'd have lots of best friends, and everything would be happy. And the other thing is that we can use it in scripting when you get even more advanced. So you can do different kinds of looping of your processes. Okay. So Idrizi, which we'll get to a little bit later, they have something called Macro Modeler. Looks very familiar, right? The model builder. Same idea, where you've got, in Idrizi, your little icons are going to be different, but essentially you're doing the same thing. You're drawing, you're connecting your data inputs to your processing steps, and you're ending up with an output. And so you can build really big models. You feel really excited about how logical your analysis is going to be. So again, why we do it is because whenever we have complicated workflow processes, we can automate it, we can string it together, we can make it much more simpler. An example is if we wanted to take those census tracts and we wanted to generate neighborhoods for a city, instead of having to go through each one of those steps that you guys are more familiar with now, you just go through it in a model. So, getting a little repetitive here, but this is what it's going to look like. When you save your models, they get saved under your toolbox, under My Tools. This will be what your model is going to look like. And it's going to show you, this is the icon for your model. This is what the model builder window looks like. You guys have seen that from last week. This is just showing you the process that they're going to go through with your tiger map and how you're going to get to this. We don't have to go through this whole thing. Okay, so geoprocessing options. It's on your, where I just showed you guys in ArcGIS, where I showed you the link to get to the to the website. There's also a tool here where you can choose how to set your geoprocessing options. If you want to do things like overwrite the outputs of operations, so if you're going through something multiple times, maybe you want it all to get overwritten automatically instead of having the pop-ups come on. If you need a log, if you're going through a complicated geoprocessing task, maybe you want a log to be generated so you know what all those steps were, different outputs. Just to choose to change in your options menu. So if you're going to go through and create a new tool under catalog, you can go and you actually have the option of when you go under new in catalog, like you did in your lab to create a geodatabase, right? You'll see if you were going to create your geodatabase here, another thing you can choose to create is a toolbox. It's showing us the process, so you guys have all of this in your PowerPoint slides, so you can go back and look at how it goes. And you can create a model. That way your model is going to get saved automatically here. Remember, the other way you can do that is if you have created the model, you can just choose to save it, and it will go through, and you can choose where it's going to get saved. And we went through this process of how we add our tools. Remember, you can drag them and drop them in. Do you guys remember me going through that process, or were you? Is it helpful when I go through that, or is it more helpful to have the slides so you can follow it? Or is it helpful to have both? Last time? Yeah. Okay. Okay.
I might have.
Okay. Feedback's always good. Because it's really a very helpful tool to have, but I realized I kind of threw it at you at the end of class last time. Then we can go through another exercise to show you guys how to do it. This is just going to show you the slides of the process. So if you wanted to join this, you can either drag your join from your toolbox. You could actually just drag it over here, or you can go and you can add it under model. It'll give you the option of adding tools.
What is this? I do have a question.
Yeah.
So you create a model, and then how does it you take features and basically run them through the model?
Mm-hmm.
And so does it build stuff out automatically? You have to make that added.
You build the model. So that's what we're doing right here.
Okay. I guess I'm just waiting to see.
Sure. Yeah. Well, here. Mm-hmm. And it automatically fills it in. See, watch. See, we just added join, and what it does is it's going to pop up the menu for you, and it's going to ask you what you want to join here.
Oh, okay.
Yeah. And then what happens after you fill out that menu is that it generates this for you. This is just showing you. See, these are your input layers that you gave it from join. You chose tracks and crosswalk, and here's your tracks and your crosswalk going into your tool, into join, and then this is your output. Yeah. Because things are so familiar to me, if they seem abstract to you, stop me, because I feel like we're seeing things differently, so it helps me to know if you guys aren't following. Okay, and then what you end up with here is a more complicated. This was the first step we just saw with these two. You added join, you filled in that table, and it created this first step. And then what you did is you went through more steps. You added dissolve, and it connected it to the output. So the model gets built as you think about what are those processing steps you need to add. You add them to your model, and it generates this map by how you're connecting those. Okay? Okay. Now the other thing that you can do is you can do it in scripts through Python. That's the language that Esri uses. We're not going to go through an example of that today, but we can do that. If you guys are interested in learning more about that, I can create an example for like next week. if you guys would like to learn more about that. Okay, there's also tutorials on Esri. They have this thing called the Esri Virtual Campus, which you guys have access to. Through your help, you can just search for things. If you want to know more about, say, model building or scripting, you can go through. They have these great little short courses, which are all very helpful. Okay, this is just an example of what the Python environment looks like. Under your, you open up the Python window, and then you have to learn some basic programming to get it to load and do the processing. But what you can see is that in Python, instead of having to go through that process of pulling in every tool, you learn how to add each type of analysis. You, as a more experienced user at this point, would know what the inputs are, what the output is, and what the other attributes that or components you need to add to that. So you needed to, you wanted to create a buffer of spools of 100 feet. So you added spools as your input layer. This is your output layer, and 100 feet was the unit that you were creating that buffer, the distance. So it becomes even more automated. Again, here's a link to the Python tutorial if we want to learn more, and I can do some more exercises with that and with Model Builder next week if you guys want. Okay, so that was the end of the second geoprocessing lecture, and I wanted to take a couple of minutes to talk about kind of what the potential project ideas, the beginning of project ideas for the midterm project, since that's coming up pretty quickly. Yeah. But the midterm project isn't as big of a project as your final project. I'm going to have you guys work in teams to do it, and I'm going to give you a couple of project ideas, unless you have something that you have come up with that you want to work on separately. Andrew, I know you might have some ideas that you want to spend your energy on for a midterm. Maybe Michael does too. Does anybody else have ideas that they... No? Brian? Sure, if you'd let, yeah.
Okay, so the county I'm from has a lot of that.
North Carolina, or?
Yeah.
Yep.
Like a cost amount for the population of the county, so I want to make that.
Yeah. Okay. Don't put my name on it. Remember that the importance of being sensitive. Pseudonym. Yeah.
Well, because that's something that's been a while.
Cool. So, what are you thinking of as things that are like correlates there?
I'd have to. I don't know. Mostly.
Yeah, so just use like census data.
Yeah.
Okay. You can create your own map. If you're thinking about it like a location analysis, you could create your own map. Okay. Yeah, we can talk more about that, but good. I'm glad you have an idea that you want to explore further. So I encourage you guys to, if you have an idea that you want to play around with, that's great. If you don't, that's fine too. There are a bunch of things that we've done in the past. I've liked to take you guys over to Reynolda and work over there. Have you guys been to Reynolda Gardens? You walk around there. I'm always amazed that some people just never make that walk. You're a sophomore, right, Caroline? So it's okay. You've got more time. But it's a really great resource. It's a beautiful place. Not only in the actual gardens, but then all of the trails that they have. And we've done a couple of things over there in the past that are actually not represented very well on this website. If you go to Reynolda, you scroll down, it gives you a link to the Science at Reynolda website. And we are only represented in one of these, the Golf Links Meadow project. Does anybody know about what they're trying to do over there to try to restore the meadow to a more, I'm going to say it, native plant meadow? They're talking about, using prescribed burning, and on Tuesday, I'm hoping that one of the grad students who works on this is going to meet us over there, and he can tell us more about sort of the whole idea and the plan that they have for the long-term management to try to bring it back to a sort of a native prairie that was present in North Carolina that's been pretty much eliminated as a habitat type. So it's a really cool project that they're working on, and they've set up plots where they're doing sampling and some of the other ecology courses. Anybody worked on that project? That's really a lot, yeah. So is that the native? Well, have you? But that's more. That's coastal, right?
No, it's like down
The
by
sandhills are.
where it's really less than where we're at.
Mm. Yeah, complicated, the burning thing. And you guys know about the Pecosins of North Carolina? Pecosins? Who's from North Carolina? You guys? Yeah. So Pecosins it's like a bog. Up north we call them bogs. They're these peatlands, really, really deep deposits of peat soils out on the coastal plain. What exactly the formations are that cause them to be there, I'm not exactly sure. I think there's a lot of questions around that. But my other job, I work for a company that helps develop carbon projects. And one thing that peat soils are really, really rich in carbon. They store carbon for, thousands and thousands of years. They have caught fire in some places, which is a really bad thing, especially in North Carolina. I'm going to forget what exact years there were some huge fires. Because like humans have always done, one thing we've hated forever and ever are wetlands. So we've drained them. There was this dream that during the Carter administration that these Pecosins were going to be like the next breadbasket. So there was a huge amount of energy invested in digging these ditches and trying to drain all of the water out of the Pecosins, which turns out they're really bad for agricultural production because all the nutrients get bound up in the peat soil. So if they do produce anything, it's after you add enormous amounts of fertilizers to them. So a lot of that has been abandoned, but the relics of all of the drainage are still there. So they're dried out. So when fires get started, they can be almost impossible to put out because they go so deep down into the soils. So there were some really, really big fires. And how does that relate to where we are now? I'm forgetting exactly how we got onto Pecosins. But North Carolina is a very interesting state. Native sandhill fire frequency. That's where we got there. That's how we got there. So the project here is trying to do a restoration of some of those native prairies out in that enormous field at Reynolda Gardens. So we're going to meet, I hope, on Tuesday morning, a grad student who's going to show us where their plots are. We're actually going to delineate the plots for them because they don't have that map, and start sort of our first exercise over there about doing some mapping for Reynolda Gardens. This is showing the first time we had this class or we did this project was when they were first starting to think about it, and we were trying to get kind of a broad evaluation of what was out there. So this is an example of a midterm project that was done in this class. And you can see this time they had 3 students working on it together. 3 is okay. It doesn't have to be just pairs. So we're going to go and we're going to do they want another map of the area of the meadow that they're working with. And we're going to plot out the new plots that they've developed, and we'll go from there. But the other thing that I'm thinking about as a potential midterm project is they want a better map. They want a trail map created that has distances that people may be able to interact with. They're not exactly sure what that's going to look like because they're not GIS savvy at all. But to go through and to get these trails, this is the art museum. You guys, have you walked the trails out there before? So you know this is a pretty basic representation of what that looks like. So there's some side trails, there's some benches. So that's another thing that we can do for them as part of our midterm. On the science site, they have this description of GIS that somebody was apparently going to go through and do these measurements, but as far as I can tell, they were never done, or if they were ever done, they were never uploaded. So the final component of doing that project would be to make sure that it actually gets completed and shared with everyone too. So that's a very kind of hands-on idea for a project too. And when we meet, we're going to meet with one of the, I'm not exactly sure who, but someone from Reynolda Gardens as well, and they're going to tell us more about some things that they might have as potential project ideas. So just to get you guys thinking about some of the things that we could be working on as projects, what I'm thinking about. So you can kind of between now and Tuesday, you don't have to actively like finalize an idea, but just think if there's something else that you would like to be working on, that's fine too. Okay, so we just had a big anniversary, changing topics here to another idea I'm thinking about for you guys for projects. This is probably going to be more of a end of the semester project because we don't have all. We're going to build on our data collection and our exposure to this a little bit more. But you guys remember the coal ash spill in the Dan River last year? Big time news, right? Big, crappy, awful news. And it's still going on because there's just a lot of uncertainty about what all the impacts were. There's also the problem that this is not a one-time concern. This is a problem all over the place. There's a lot of coal-fired power plants. There's a lot in North Carolina. Some of the worst potential contamination sources for our rivers. So I'm thinking we might want to work on this a little bit more too. Both looking at mapping what happened, mapping the potential for other problems, and looking at that really. As far as I can find, this is like the only map that there is for North Carolina of potential contamination sites, and it's really not very interactive. So I think we can improve upon this. And the other thing is I talked to you guys, I mentioned last class about, the River Keepers program. So I talked to Will, I'm going to forget his last name right now, who's the Yadkin River Keeper. And he's going to come and talk to us about stuff that they're working on. And they're in a big process of trying to identify non-point source pollution problems in our river basin. And they've gone through and mapped out a lot of agricultural sites. There's a lot of chicken production that goes on, and that's a big source of nitrogen and phosphorus, and it feeds into our water system. So that's another thing I'm thinking would be a really interesting project, and also is going to build off of some of the stuff you guys have already become quite familiar with the rivers and the river basin. So those things sound pretty interesting. Any questions? Michael, you stepped out, but I said I don't know if you're thinking about a project separate for your midterm project. Is there something you're thinking about working on already? But these are just project ideas that we're starting to generate. Okay. So what we're going to do too is, because we really only have like next week, we'll spend next week's lab. We'll decide on the projects, and then next week's lab you will work in teams to work on finishing or building to finish that project. So we'll have it all kind of ironed out by next Thursday. Okay. Okay, great. How's my speed? Am I doing okay? I'm always trying to figure out if I'm going too fast or too slow. I have, because we missed a lecture, I'm going to start on another one. It's 11:45, so we have another half an hour. Okay. And we're going to work on editing in our lab today. So if you need to stand up and stretch your legs and make your brains work again, please do so. I'm just going to upload your next lecture.
I mean, it's fun. So it is. I have another startup project.
Yeah.
The final project.
Yeah.
So, I guess I was listening to Dr. Brown's last sprint, and I was doing, I guess, writing paper on like gases.
Uh-huh.
I was kind of changed over time to all that stuff. And it's apparently impossible. And the metal contamination in the soil and the sediment and all kinds of things, which is interesting because it's also controversial.
Mm-hmm.
And I don't really know what I want to do,
Mm-hmm.
but I think it'd be fun to kind of incorporate that research into this.
Yeah.
Because I wanted to do like a project, but I don't know.
Yeah. And the other part of that I was bummed because that when I said that a lot of our analysis from before is not on their website. Somebody did a project looking at mapping out the wetlands, like trying to delineate, because I think that's another thing that they don't have.
There was one like old map that we had shot it.
Mm-hmm.
Like things that just colored
Okay. Let me try and find the data that they generated, because I think, and that then you could maybe have a better idea of what was done, because it took a lot of effort. I mean, he was in waders and they walked like the whole perimeter. So yeah, he was I think he was a duck hunter, so he enjoyed the whole process. But we definitely have something to work from that could maybe help you think about what, building from other people's work is the way to go. Sorry, I'm getting buzzed here. So yeah, let me see if I can find the maps, the data points that they have.